regulate the flow. You are having a run to regulate the flow. And water flows into the tank and the water flows into this tank and the detox is provided over here and water flows out of the detox. So now what we will do initially is we have more water into it and we have determined the height to which the water just spill out of this triangle. Now actually we have kept a constant flow rate in that into the pump and water is overflowing to the source and we have noted the reading then the water was just spilling over in this triangle. Now it is going at a specific flow rate. Now if the water is calculated in the measuring tank and the measuring tank is of dimensions 30 by 30 centimeter, 30 centimeter by 30 centimeter and what we will do is we will keep that flow rate constant. Keeping that flow rate constant we will determine time period for 1 centimeter or 2 centimeter level. And for that what we will do is we will close this valve so that water will get accumulated in this tank.
Hello everyone, was the audio was you able to hear the audio?
Not so clear.
Not so clear, okay. Because there is a little bit of network issue over here, so that is what I will just try to make it in a Chrome tab presentation. The next one, two videos are there. So basically the practical is all about measuring the discharge coefficient of discharge of the notch. Okay, the triangular notch. Now coefficient of discharge is defined as the ratio of the actual discharge to that of the theoretical discharge. Okay, so the actual discharge you can find it out by means of the measuring tank, which is having a dimensions of 30 centimeter by 30 centimeter, and the theoretical discharge I will mention it in the calculation section how to calculate the theoretical discharge. So now the basic thing is that by means of a pump, water is pumped onto an overhead tank which is provided with a triangular nose to measure the flow rate. So what we do initially is when the water just spills over, मतलब जब वो मतलब triangular node से बाहर निकलता हुआ रहेगा, तो then हम लोग what we will do is we will measure the level, and when you are having a sufficient amount of head above that above the crest that you may tell it as the crest, the V shape में जो आता है, that is called as the crest. Whenever you are having a sufficient amount of head of water above the crest, right, we will make the flow rate constant and maintain that constant head so that water spills over continuously over the notch into the collecting tank. Okay, so the difference in the height when the water just spills over the notch and the head which is maintained above that crest of the notch, the difference is calculated, and that difference in reading is used to calculate the theoretical discharge. Okay, so now I will just make present now.
the level is nearing to 11, and once it reaches 12, I will start the stopwatch. So So I will note the readings as 1 centimeter in 5.1 seconds. For the next reading, we will increase the flow rate and we will keep the flow rate steady. And once it becomes steady, then we will repeat the same kind of readings per second. And the remaining set of readings and calculations will be discussed in the online practical sessions. Thank you.
Okay, so I hope everybody was able to get the feel of the practicals. Okay, so what we will do now is we will start looking at how to do the calculations for this practicals. Okay, so before that I will just share the screen so that you can have the observations and calculations that is visible for you. Okay, so चाबी उधर देना है बाजू में। दोनों करके जाओ अब उधर ही रहने दो उधर ही रहने दो हम मैं बस जस्ट मैं लॉक कर दूंगा चिंता मत करना मैं दे दूंगा चाबी मैं चाबी दे दूंगा हम हाँ मैं वो दोनों बंद करके चाबी दे दूंगा वहां पर चिंता मत करना प्रैक्टिकल चल रहा है इसलिए
Hello, sir.
Hello. Any point which needs to be discussed, or shall I have to because the mic was switched off? Once again, I will just tell you the calculations how to do it. Okay. So just we'll just finish it out in 1 minute. Okay. You are having the difference in the height of the tank as 1 centimeter. Okay. So difference in the height of the tank is 1 centimeter. The time that is taken is 5.1 seconds. The cross sectional area is 0.09. So the difference in the pointer reading was 3 centimeters. Okay. So the height difference of since the height difference was 1 centimeter, the volume of the water that is collected in the measuring tank is 0.09 into 0.01. Okay. So that is 0.0009 meter cube. So the time taken is 5.1 seconds. So the volumetric flow rate is 0.0009 by 5.1. So that is equal to 0.000176 meter cube per second. So the actual flow rate is 0.000176 meter cube per second. Now the theoretical flow rate, we can calculate it from this readings. That is Q theoretical is equal to 8 by 15 and the square root of 2g into tan theta by 2 into h raised to 5 by 2. Okay, so we can input these values. 8 by 15, g is 9.8, theta, that is the angle of the v naught, which is 75 degrees, and h is the height above the crest of the notch. That is 7 centimeter was the reading when the water was just spilling over the notch. And the final pointer reading refers to the head above the crest of notch whenever you are having a constant flow rate of the water. So 3 centimeter refers to the difference in that pointer readings. So you can calculate theoretical flow rate from this, and the coefficient of discharge is the ratio of actual flow rate to that of theoretical flow rate. Actual flow rate you have calculated from this one, and the theoretical flow rate we can calculate it from the corresponding equation which is as shown. Any doubts? I will send this set of calculations and the readings so that you can write. You should have to start doing this. Start writing the practicals in the fair pages also, because otherwise whenever you come back the volume of the assignments will become more and more. So any doubts? कोई भी डाउट है तो बता दीजिए आप लोग.